Hello 108 students, Mr. McHugh here. Welcome to the beginning of section 5.4 where we are going to focus on multiplying polynomials, and we're going to go ahead and tackle page 1. Okay, so let's go ahead and get red mode going here. Hopefully that shows up a little clearer. We're going to do some basic multiplication. Objective 1 is review material here. What happens if you're multiplying a single term times another term, or a monomial times a monomial? Our decoder rings tell us there's assumed multiplication going on here, and basically you just multiply the coefficients. Negative 4 times 3 produces negative 12, and whenever you multiply by the same base class, what do you do with the exponents? 3 blank 5. That's right, you add them and you get your answer of 8. Okay, so over here's another example, same idea, a couple more terms. Multiply the coefficients, 2 times 8, 16. Now you multiply m squared times, going a little too far, m to the third produces what? Add the exponents, m to the fifth. Multiply z to the fourth times z to the squared. Add 4 plus 2, result m to the sixth. Okay, so that's pretty cool. That's just a warm-up exercise to get us going. Multiplying two polynomials. What happens if you see some parentheses, class? What goes on between the outside of the parentheses and any term in front of it? Usually you used to think of just seeing a number or just a single number. Now we're going to have a term like 5x squared. It's multiplied, so we are going to use the distributive property and take 5x squared and times each of the terms inside the parentheses. Okay, so that's what you're doing. 3 terms, 4 terms, 5 terms, wouldn't matter. You still would distribute to get rid of the parentheses and multiply by the first term in front. Okay, so when you do that, they're practicing you taking 5 times 4 is negative 20, x squared times x squared, x to the fourth, because you added 2 plus 2, and you guys are kind of getting the idea. 5x squared times 3x, 15, x to the third, 5x squared times negative 2, negative 10, x squared. Don't forget to add exponents when you multiply by the same base. Okay, so now we hit a situation here on objective 3. Let me kind of come down here and lock us in a little bit. Multiplying two binomials. What are you going to do when you multiply one binomial, which again, binomial is 2 terms, something like x plus 2, and there's assumed multiplication. I like to put the dot over and emphasize it. X plus 3 is the second. Okay, now back in 025 you might have had your instructor told you about double distributive property. I'm sure most of them, if not all of them, told you about how to use FOIL, and we recommend that you use that because we're going to use reverse FOIL technique in chapter 6. Okay, so what does that mean here? It says FOIL stands for first, outer, inner, last. Now this first example I'm going to explain all the gory details here, so be patient with me. Hopefully a lot of you guys remember this from 025 or back from your algebra days, and you just remember this rule only applies when you're multiplying two binomials. That's the only time. Okay, first means multiply the 2 first terms. Now I like to use these little pairing lines, x times x. So over here I have FOIL, first, outer, inner, last. The first term times the first term is x times x. Okay, that would drop down to x squared. Next one is the outer. Multiply the 2 terms on the outside away from each other. X times 3. There you have here's the work right here, and the result is 3x. Inner is multiplying the 2 terms that touch each other, the ones that are on the inside. 2 times x, which I've got right here, is 2 times x is 2x. And finally, last is multiplying the 2 terms, the last term of each of the parentheses of the binomials. So you've got 2 times 3, and you've got the result of 6 there. Okay, almost always when you multiply these, the outer and the inner are going to combine. So 3x plus 2x combines to 5x, and here's your final answer, x squared plus 5x plus 6. Okay, now this is straight regular FOIL. It's easy to do, it's mechanical, it never changes. When we get to chapter 6, we are going to take this trinomial and factor it, which is going to require us to go back to reverse FOIL. Now we're not doing that today, but just keep that in mind. That's why it's important that you understand how to use FOIL, first, outer, inner, last. Okay, so let's go look at example 4a. Are you multiplying two binomials in this problem? Yes. Can you practice first, outer, inner, last? Okay, now what you might do here is just to get some practice, you might rate the F, O, and the I, and the L, give yourself a little space, and now you start, and you can use pairing lines. So the first terms, 4m times 3m, result 12m squared. Outer, 4m times 1 is 4m. Inner is negative 5 times 3m, which is negative 15. And finally, last term, negative 5 times a positive 1 is a negative 5. And all you have to do now a lot of you guys, guys and gals, excuse me, you're going to come down here and come straight down to here, okay? I just want to make sure you clearly understand how to do first, outer, inner, last. And then you're going to almost always combine the outer and the inner. So 4 minus 15 is a negative 11. And boom, there you go. There's your answer. Okay, let's try 4C here. Be careful. Sometimes they'll put two letters in here, so whatever you have in the first terms, multiply them. So we're going to take 2k times 5k. I wrote FOIL to set it up. So 2k times 5k is 10k squared. Okay, do your last. 2k times a minus 3z minus 6kz. 2 times 3 is negative 6kz. That was the outer, now here's the inner. 3 times 5 is 15kz. Oh, by the way, when it comes to letters, which one comes first? They go in alphabetical order. That's why I put the k first. Finally, last, 3z times a negative 3z would be negative 9z squared. Okay, and you can combine the outer and inner, like you can see here, negative 6 plus 15 will be 9kz, and there's your answer. Okay, good job. We have finished up page 1 of our multiplying polynomials. We've got a couple more to go, so I will see you for page 2 on the next video. Okay, take care. Bye.